Hi, I'm Philip. I acted as a team leader and I helped design the piping systems as well as specified the pump and the control valve. Navistar is a leading manufacturer of heavy duty vehicles. They have a research and development center here in San Antonio, and their thermal management validation team has tasked us, Surefire Engineering, with designing and manufacturing a test bench to test their turbine flow rate transducers that they use in their testing. Surefire Engineering has been working with a team from the electrical and computer engineering department here at UTSA to complete this project. Surefire Engineering has been in charge of the mechanical aspect of this project, and Horsepower Engineering, the ECE team, has been in charge of the electrical components of this project.
Hi, my name is Gabriel Flores. I worked as a mechanical engineer on the flow transducer test bench, and I designed part of the structural aspect of the test bench. So the purpose of the flow transducer test bench is that Navistar right now doesn't have a in-house way of verifying whether the sensors work or not. Instead, while they're testing, they check for these transducers and see if they're faulty or not, and that takes them a long time to verify. That means that they have to end the test, drain out fluid, and that's when they know whether it's a faulty sensor or not. And so when this test bench comes in is so that we can save time, and it can be a much more reliable system of checking whether these transducers are actually working and whether they're reading their actual output of flow. And my role was designing the structural part of the test bench, which includes making sure that the structure of this test bench actually can hold all the forces and all the pressures that this pump and the valve will be outputting.
Hello, I am Cyrus Berg, and I primarily worked as a CAD engineer on this project. For technical objectives, we were tasked to design a flow bench that would have interchangeable sizes down from 1/2 inch diameter to a 3-inch diameter flow rate transducer. They wanted us to minimize the amount of parts that were swapped out between tests for different variations of sizes, and they wanted us to use as many off-the-shelf parts as possible. So our design used 90% of the parts came from Navistar, minus about 2 parts, the valve and the pump. Basically, our CAD model shows that the final design CAD is true to life, and the way the system works is, if you look at our P&ID diagram, you have a tank that holds fluid. In this case, it would be engine coolant, and that flows down through a section. This is mirrored from the actual geometry. It flows down to the pump. The pump then pumps it up through the magnetic flow meter, which will read the primary master sensor that it's acting as, and it flows up through a 90 into the tested sensor, which is not depicted here as we did not have a CAD model of that. And then it flows through the valve, and this valve is actuated via electronics supplied by Horsepower Engineering, and the valve will be controlled to close to increase back pressure and decrease flow rate, or vice versa, depending on the flow rate to be tested based on the diameter of the flow meter.
My name is Hugh, and I was the quality engineer for this project, for the flow rate transducer test bench. Okay, so for the flow rate transducer test bench, we're going to perform 11 tests total. These tests consist of stability, vibration, leakage, and the actual verification between the master flow sensor and the test sensor, which our master flow sensor was a magnetic flow sensor and the other one was a turbine sensor. The turbine sensor is actually the one that goes into the actual engines, but these tests have yet to be finalized because we're waiting for the final components from the actual electrical team, and the only tests we could have done were the actual physical ones compared to the electrical ones. And my role in this was kind of a quality engineer role and just making sure everything either worked out engineering analysis wise or all the components work together.
Hi, my name is Ivo Barrientos, and I was a fluid engineer working on the head of the system. In terms of this, summary statement, Surefire Engineering has met all mechanical designs. Okay. Surefire Engineering has met all design and manufacturing requirements for this project. We are currently pending on horsepower engineering to finish and finalize their electrical system in order to continue testing. Testing will be done on site at the